Working with exponential equations sometimes can be proven complicated or confusing. You need to remember that all exponential equations can be handled the same way, but we have different exponential equations that they look different. And depending on how the initial form of the exponential equation that you have has, you can decide what to do first and what to do next. So I'm going to divide the set of exponential equations that you may come across into different types. So let's look first of all the simplest type of equations, that are the ones that you have two sides of the equation, and on both sides you have powers that they have the same base. So as you can see right here, I have the same base on both sides of my equation, and there is nothing else involved in this equation than these two powers. What does this equation tell me? It basically, if you want to read it, says what you want to do here is to find that number that if you raise 3 into that number is going to be equal to, if you raise 3, to 2 times this number minus 1. Okay, now the first thing that you want to say is that the bases are the same. Let's look at what happens if you have, let's say, 3 to the second and you have 3 to the 1 plus 1. Well, if the bases are the same, if the powers are the same, then the exponents must be the same, obviously, because there is no way that you can have 3 to the second equal to 3 to the third. It wouldn't make any sense. It's not correct. So if the bases are the same, then this means that the exponents are the same. So if you have this situation where the bases are the same, you focus on the exponents. The exponents must be the same. So let me write this here. The exponents, in this case, must be equal. What does this tell me? This tells me that if the bases are the same, then I can focus on my exponents and I can set them equal, because they must be equal. So this means that x must be equal to 2x minus 1. Well, this gives me a linear equation, a very simple equation that I can solve for x. I move all my variable terms on the one side, and I have x minus 2x equals to negative 1. I combine the like terms, and I have x minus 2x negative x equals to negative 1. And I simplify the signs here, and I have x equals to 1. And this will be the answer for this equation right here. Now, since the exponent must be equal, this transfer as the answer for this equation. Now, let's verify this. 3 to the first is equal to 3 to the 2 times 1 minus 1. Well, if you simplify this gives you 2 minus 1, 1. So basically you have what? 3 to the first equals to 3 to the first. So we're good. Now, whenever you have equations, exponential equations, and how do you recognize them? You recognize them because the x is at the exponent. So if you have exponential equation where the bases are equal, then immediately this means that the exponent should be equal. Forget about your bases, focus on the exponent, solve the equation of the exponent, get your answer. That's your answer for your initial equation. Now let's look what happens if I have an equation where I have only one power, and on the other side of the equation I have a number. So let's assume that I have 3 to the 5x plus 2 equals to 1. What should I do about that? Well, right here it's a little bit more confusing because I have a power right here, but right here I cannot say that this is equal to that because it's not. I have 3 and I have 1. So what should I do? The way that you should work this problem is by finding a way to express 1 right here as a power of 3. Well, we should remember what? That any number raised to 0 is equal to 1. So instead of having 1 here, I am also able to write it as 3, 5x plus 2 equals to 3 to the 0. Now what did I do? I managed to write my expression, my equation, as an equation that has the same base for the powers on the left and right. Now I can follow the steps that I did for the first set of equations, and I can say that 5x plus 2 is equal to 0, solve for x, and this will be the solution for my initial equation. So x will be equal to negative 2 over 5, and that's my answer. Now, it is not always possible to rewrite a number like this 1 right here, that is a beautiful number, as a power of 3. Later, I'm going to show you a trick on how to change any number as a power of any number, because you know a very important rule of logarithms that they allow you to do this. For the